Hello everyone. Hey guys, this is your JEE educator Megha. I hope I'm audible to all of you. If it is fine, please do let me know once with a chat. Let me see if everything is fine. Hey guys, I hope everything is fine. Am I audible to all of you? If you are live for this session, then please give a hi so that I get a confirmation from you. This is our first live session for chemistry. I want to tell you guys, over the Unacademy JEE English channel, we are going to brought up the content for all our students, those who want to learn in English language, okay? So guys, our whole focus is that you go through the concepts which are difficult concepts so that we could make them very easy for you. So the very first topic that I picked for you guys is periodicity, periodic properties, okay? So I have given you all the lectures related to the atomic radii, ionization energy, atomic radii, electron affinity, electronegativity, what are its applications, what happens for the acidic and basic character of the oxides and something. So all the part has been covered. If you have missed any of the lecture, you please go through the recorded ones and check them, okay? And if you have any doubt, please do let us know. We'll definitely make sure that your queries gets resolved, okay? So here today we are having this live session for you all, which is on the previous year questions, and the previous year questions has been taken from the very important chapter, that is periodicity. Okay, so I hope you all are ready to begin with this. In total, I will be giving you 20 questions, and yeah, these questions you have to answer them first, and if in case you are not able to answer them, I will be giving you the detailed explanation, okay, so that there must be a learning, okay? So definitely whatever the time you are going to invest in this session, this will give you some output, okay? So let's go ahead guys. These are the topics on which you will be getting questions related to the atomic radii, ionization energy, electron affinity, electronegativity, and the acidic and basic character, strength of oxides and oxyacids. So along the period or along the group, what happens, we have seen many times. Now it's a time to do questions. So this is my very question number 1, which says that the correct order of acidic strength is, okay? So this is a question you have been given with the oxides. Just have a look that what would be the acidic strength when we have an oxide of chlorine, sulfur, phosphorus. All they are different. This is carbon, nitrogen, sulfur, sodium, magnesium, aluminium, and potassium, calcium, and magnesium. So we are having the oxides of all such metals and non-metals. So try to figure it out. What would be the right answer for the acidic strength? And please do let me know your answers. I'm looking for your chat. Okay. Hello Ganga. Hi bache. Ganga or Gagan? It's Ganga only. Okay. Yes guys. I have not yet received any of the answer. कोई बात नहीं, I will be keep waiting. Okay. Hello Pratiksha. So yes, let us have a discussion on this question, okay? This could be quite easy. Let's have a look. So guys, whenever you have the oxides of different metals, here we have a chlorine, we have a sulfur and phosphorus. So it is always better to answer your question depending upon the electronegativity. As you can see that if I am talking about the chlorine, the sulfur and the phosphorus. They all belongs to period number 3. So we are moving from left to right, and when we are moving from left to right, this is the oxide of phosphorus, which is P4O10, oxide of sulfur, which is SO2, this is the oxide of chlorine, which is Cl2O7. So here what is happening? The electronegativity increases, and as the electronegativity increases, the acidic character increases. Okay, so the acidic character of chlorine has to be greater than that of sulfur, than that of phosphorus. This means this is the correct order. This is the correct order. Now what about the carbon, nitrogen, sulfur? Look, let's have a look. They belongs to the period number 2 and period number 3. If you would see, carbon comes in group number 14, then we have nitrogen, and this is oxygen, and this is sulfur. So the question is saying you have a CO2, you have a N2O5, and you have a sulfur, which is sulfur trioxide. So what happened? If you would see, if you would be comparing between these two, CO2 and N2O5, nitrogen is more electronegative. So definitely N2O5 is going to be more acidic than that of the CO2. So ultimately N2O5 has to be more acidic than that of CO2. Reason being electronegativity, because we know electronegativity increases, the acidic character increases. Is the NO2 is more acidic than CO2? No, as per this option. So this is incorrect. Okay, and if you ask me, ma'am, what about sulfur? Of course, sulfur and nitrogen, if you would see their electronegativity, sulfur belongs to the period number 3 and the nitrogen belongs to the period number 2. So the period number 2 elements, as we go down the group, the size increases, the electronegativity decreases. Okay, so here the N2O5 itself will be more acidic than that of the SO3. So this order was right, but this order was wrong. Now let's have a look over the Na2O and MgO and Al2O3, where they are. So let's have a look where they are in our periodic table. If you would see sodium, we know that lithium, sodium, sodium we get here. Let me write it again. Sodium we get here, Li, Na, K, Rb and Cs, right? So here the question is giving us sodium, okay, where the magnesium comes here, Be, Mg, Ca, right? So here we have a magnesium. Aluminium comes after boron, that is here. So they all belongs to period number 3. Now guys, you already know, as we go from left to right, the electronegativity increases, the acidic character increases. So of course, aluminium oxide has to be more acidic than the magnesium oxide, than the sodium oxide. So ultimately the given order is incorrect. So what is the golden rule? If you have the oxides of different elements, please look at them at their electronegativity property, electronegative. Okay. Now we have the last option, that is the option number D, which is saying you have a K2O, you have a calcium and magnesium. So where does they belongs to? They belongs to period number 4. You can see that they are in period number 4, which is K2O, CaO and magnesium. Magnesium is this, okay, calcium and magnesium. So if I compare between the K2O and CaO, K2O is more basic, okay, so they are all metals, so metals are going to be basic, they are not acidic, okay, but if still the question is asking about the acidic strength, we know that as we go from left to right, the electronegativity increases, the acidic character increases. So the K2O is least acidic than the calcium oxide. Okay, now if there is a comparison between the magnesium and calcium, then again magnesium is smaller in size, has more Z effective, more electronegative as compared to that of the calcium. So I should not compare basically for their acidic strength, because we all know they are metals and metals forms basic oxides. Okay, they forms basic oxides. Okay, and here we got to know ki okay, in between the K2O and CaO has to be more acidic as compared to that of the K2O. So this order is also incorrect. Okay, so as per this, the right answer for the question is option number A. So I want to see who all are there. Ganga Ishanvi and Abhi the Rockstar came from Telegram group. Okay, you Rockstar. So guys, are you ready to answer all those questions? Okay, please be there throughout the session. This session is going to help you a lot. Okay, all the detailed explanation of all such questions will give you a chance to learn. Okay, chalo. So here let's move to the another question. Among the H2O, H2S, H2SE and H2TE, the one with the highest boiling point, Absolutely. When there would be a question related to this, so what would be the reason for the boiling point? When the boiling point increases, this is a physical property. When this physical property gets affected, the answer, read out your options. H2 because of the higher molecular weight, H2O because of hydrogen bonding, H2S because of hydrogen bonding, and H2SE because of lower molecular weight. The right answer is Danav Gaming. What's your answer, bache? Yes, the right answer for this question is option number B, means H2O because of hydrogen bonding. What's the reason behind it? Guys, you know, boiling point. Boiling point means if there will be more interaction between the molecules. Then if H2O will show the hydrogen bonding. Let's say this is one H2O, this is the another H2O, this is the another H2O. So we will be having hydrogen bonding in between these molecules, like the H positive of this will react with O negative of this, and this is a hydrogen bond formation. This bond is hydrogen bond. Okay. And again this hydrogen will form a hydrogen bond with this oxygen. So ultimately so many water molecules will combine together and there will be interaction because of the hydrogen bonding. There we will be having the interaction. A large aggregate will form. Ultimately the molecular weight will increase, and as the molecular weight increases, the interaction increases, the boiling point increases. Why the boiling point increases? Because now we need more temperature to break such bonds so that the water can be converted from its liquid state to the vapor state. Okay, so the conversion from its liquid to vapor is basically the temperature which is being required to convert any of the molecule from its liquid to gaseous. Okay, so this is our boiling point. So here the right answer is water. If you are looking for H2S, but sulfur does not show hydrogen bonding. Okay, sulfur does not show hydrogen bonding. Hydrogen bonding can only be shown by the elements which are having FON. Always remember the trick, FON, phone. Okay, so only the elements fluorine, oxygen and nitrogen can show the hydrogen bonding. Now here we have the another question. Identify the correct order of acidic strength for CO2, CuO, CaO and H2O. Okay. Again the question is from the acidic strength. What would be the right answer? Danav and Jaideep is saying the right answer has to be option number B. Is it? Option number B. Acidic strength. Check this up. Sorry, bache. The right answer for the question is option number A. Why? When we were having these compounds, we should know this is a carbon which belongs to the group number 14. This is a P block element. And CaO, calcium oxide. This is a S block element. Copper oxide is a D block element. Copper is a D block element. And water. And I already told you water is neutral. Okay? Water is neutral. So we must know about the neutral and the amphoteric oxides individually. So water is neutral. And you know the S block elements and D block elements, they are metallic in nature. They are metals. So they usually form basic oxides. This P block, carbon is a non-metal. So when you are talking about a non-metal, they form acidic oxides. Okay, they form acidic oxides. So it's very simple that this is acidic, this is neutral and this is basic. So the acidic strength order has to be CO2, then after this is acidic, then comes your water which is neutral, and then comes your basic oxides. then comes the oxides which are basic. Now in between CaO and CO, what will be the order? Guys, CaO is most basic because this belongs to S block element, and in the D block element the basic character decreases. So the right order for this question has to be this, that is the option number A. Is it clear? Okay. I got your point, Danav. Okay, good. So let us move to the another question, which is the question number 4. According to the periodic law of elements, the variation in properties of elements is related to their. If we are talking about the periodic law of elements, the variation in properties, whether it is atomic radii, ionization energy, all these properties are getting the variations. These variations are related to their nuclear masses, atomic numbers, nuclear neutron proton number ratio, or atomic masses. On what basis we have told about the variations in the properties? Answer, all of you. Very good, Danav, Ganga. The right answer is B. Absolutely amazing. Atomic numbers, है ना? Depending upon the Z, the atomic number values, we can determine the properties like atomic radii, the ionization energy, everything depending upon the atomic numbers. So B is the correct answer. Absolutely. So let's go with the another question, which is the question number 5. Which one of the following is an amphoteric oxide? I hope you might have gone through all the amphoteric oxides which I told you. So be ready to give your answer. Which one of the following is an amphoteric oxide? Chirag, your answer is for previous question or this question? Amphoteric oxide. ZNO, very nice, ZNO. This is an amphoteric oxide, right? Amphoteric oxides could be of tin, which is SNO2, ZNO, PbO, PbO2. All these are our amphoteric oxides, Al2O3, right? All these are our amphoteric oxides. If you are talking about sodium, it's a metal, it is going to form a basic. This is sulfur, which is a non-metal, it is going to be acidic. B2O3, this is also acidic. Okay, and zinc oxide is amphoteric. Very nice. Another question, which one of the following ions has the highest value of ionic radius? Which one of the following ions has the highest value of ionic radius, which will be having a large size of radii? They all are ionic species, which will be having a large size of radii. Waiting for your answer. I hope the question is visible to all of you. Bingo, Chirag. Correct answer. He is the fastest finger first. O2 negative. Why O2 negative? We know that this is lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay. So here the lithium is Li positive, boron is B plus 3, and ultimately if you would see the fluorine is F negative and oxygen is O2 negative. Okay. So when you are talking about the lithium and boron, they both are isoelectronic, and they are forming the electronic configuration that of the helium, which is smaller in size, and they are isoelectronic and forming the configuration of helium. And O2 negative and F negative, they are also isoelectronic and they are forming the electronic configuration that of the neon, and we know that as compared to helium is smaller and neon is bigger. So ultimately O2 negative and F negative are going to be bigger. Now the question is, why O2 negative is greater than F negative? Reason being, in the oxygen we have 8 protons and 10 electrons, and here in the case of the fluorine we have 10 electrons, but we have 9 protons. So they are isoelectronic, having same number of electrons. But in the case of fluorine, we will be having more Z effective, because the number of protons are greater, they will be more Z effective, so the size decreases. Okay, but with respect to oxygen, there is no such case. Less protons and more number of electrons. So ultimately there will be a repulsion between the electron, and the ionic radii will increase. And there is one more reason that we must know: when we add O negative gains one more electron and become O2 negative, there will be a large amount of electron repulsion. So because of this, whenever we do the successive addition of electron, then during the successive addition of electron, the electron repulsion increases at a faster rate, and so therefore the size of the ion increases at a faster rate. Okay, so that's the reason why O2 negative is larger in size as compared to that of the F negative. Fine? Yes. Here we go with the next question. Among the Al2O3, SiO2, P2O3 and SO2, the correct order of acidic strength is? What would be the correct order for the acidic strength? Al2O3, SiO2, P2O3 and SO2. Okay. So there is a one question, there is a one student whose name is बहुत जगह है. Oh my god. Got it, Aditya? Great, बच्चे. So what would be the answer here? Al2O3, SiO2, P2O3 and SO2. Yes, D is the correct answer. Reason being, we know that this is aluminium, then we have silica, they all belongs to period number 3. Aluminium, silica, then comes your phosphorus, and then comes your sulfur, right? So as we are moving from left to right, the electronegativity increases, so all these oxides will become more acidic. So as already we know, aluminium oxide is amphoteric, and then after the rest all are acidic, and among them, as the electronegativity increases, the acidic character increases. So this is a very important principle of acidic character. Okay, so the right answer is option number D. Another question: the formation of the oxide ion O2 negative gas requires first an exothermic and then an endothermic step as shown below. Okay, the formation of the oxide ion requires first an exothermic process. You can see that the first step is exothermic. We have a negative value, delta H is negative, and then an endothermic. Here you can see that the delta H value is positive. Okay, so this is shown below. This is because, why is it so? When we are adding the first electron, in the case of oxygen, the step is exothermic, and in the next step, when we are adding one more electron, the process becomes endothermic. Reason: O negative ion will tend to resist the addition of another electron. Oxygen has high electron affinity. Oxygen is more electronegative, or O negative ion has comparatively larger size than that of the oxygen atom. The reason: amazing. Right answer is A. O negative ion, basically when we add an electron to the oxygen, it becomes O negative very easily, and since this becomes O negative and then again we want to add one more electron, then there will be a repulsion, electron repulsion. So to compensate that repulsion, so this oxygen will try to resist the addition of this one more electron. So to compensate, to overcome that repulsion, we need to give energy. So energy is required, and if here the energy is required, the process becomes, energy is required to overcome that repulsion, to overcome that resistance or repulsion, that resistance or repulsion. Okay, that repulsion. Okay, so this process becomes endothermic. So O negative ion will tend to resist the addition of another electron. Nice. Another question: which of the following oxide is amphoteric in character? Which of the following oxide is amphoteric? Amphoteric: SnO2, SiO2, CO2 or CaO? The right answer for the question is What's the right answer for the question? Option number A. Absolutely. Why? We know that calcium, it's a metal. Metal will form a basic oxide. Okay. Carbon, it's a non-metal. Silica is also a non-metal. They both will form the acidic oxides. Okay. And only the tin, as I already told you in one of the previous question also, tin forms an amphoteric oxide. Amphoteric. Always remember all the amphoteric oxides. Another question, in which of the following arrangement the order is not according to the property indicated against it? Means the order which is not according to the property indicated against it. Which order is wrong? Okay. Related to the property which is being mentioned. Take your time and try to figure it out. Are you doing, guys? Good. The right answer for the question would be C. Absolutely. Okay, let's have a look. Okay. Great. बहुत जगह है भाई. Can't you change your name, बच्चे? Let's have a discussion. Increasing metallic radii. What happened? LINAKRB. You know, here these are all the elements belongs to group number 1. Rubber. LINAKRBCS. Okay, so what happens here? There will be the increasing number of shells. So as the number of shells increases, the size increases. It's very obvious. Yes, this is the correct order. Rp is going to be the greater than potassium, than sodium and lithium. Increasing electron gain enthalpy. Increasing electron gain enthalpy. Okay, so here we do have fluorine, chlorine, bromine and iodine. I told you in my classes as well that the chlorine belongs to period number 3. Period number 3 elements have a high electron affinity. Their electron affinity is very high. Electron affinity is higher for chlorine as compared to that of the fluorine. Reason being why the electron affinity is higher. Electron affinity is higher means positive electron affinity is higher. This means that negative electron gain enthalpy is higher. Okay, this means that I told you EA and delta EGH is the same, but they are just opposite in their sign convention. So if EA is positive, delta EGH is negative. That's why they are saying negative sign, negative electron gain enthalpy will increase. So why there is an increase? Because the reason is electron density. In the case of a chlorine, we are having a vacant d orbital, and because of the presence of extra vacant d orbital, there is less electron density. The electrons are less repelling in nature, and so therefore they will welcome the addition of electron more easily. So this upcoming electron will be added more easily into the vacant orbital of that of the chlorine. While in the case of a fluorine, the electron density is very high. Okay, here we have low electron density, but here we have very high electron density in the case of fluorine, because we have only 2s and 2p orbitals, and in the 2s we already have 2 electrons and 5 electrons. So very highly densely populated. So here we have lot of electron repulsion, so therefore the electron is very difficult to be added. Okay, so this has low electron affinity. So the fluorine electron affinity is less as compared to that of the chlorine. So yes, absolutely the right answer is this only. Okay, and as the size increases, electron affinity already decreases. So here what comes about the boron, carbon, nitrogen and oxygen, guys, here this order is wrong. Why? We already know nitrogen has high ionization energy as compared to that of the oxygen. Reason being, nitrogen has 2s2 2p3 configuration, means the half filled configurations are more stable. If half filled configurations are more stable, it will become very difficult for us to remove an electron from the nitrogen orbital and make it N positive. Okay, because here it's half filled configuration. So the answer must be N is greater than O. The electron, the ionization energy for nitrogen is greater as compared to that of the O. If we are talking about So that's how this is a wrong. The question asks which is not correct. Okay, so this is correct. I have written this is the answer. No, this is not the answer. This is a correct statement. Okay, but the question is asking which is a wrong statement. So this is a correct statement, this is a correct statement, this is a wrong statement, the correct should be this. Okay, and what about this? Here we can say that Al plus 3, they all belongs to period number 3, Al plus 3, Mg plus 2, Mg plus 2, and then after comes your sodium, sodium and F negative. So where does this sodium comes? Sodium N positive, they all belongs to period number 3. In the period number 2 we have F negative. So F negative, Na positive, Mg plus 2 and Al plus 3. They all are isoelectronic, they all are having the electronic configuration of that of the neon. They all are isoelectronic. Now how you decide the ionic size? Guys, here the fluorine is going to be larger in size. We know that as we start adding the electron there will be repulsion. There will be, this has less number of protons are less, protons are only 9 and the electrons are 10. So when we have a less proton and more electron, there we will be having repulsion, and as the repulsion increases the size increases, the size increases. So this is the reason for the question. Okay, yeah, they all are isoelectronic now, right Danav? Okay, very nice. So if we move on to the another question, following statements regarding the periodic trends of chemical reactivity of the alkali metals and the halogens are given. Which of the following statement gives the correct picture? So the periodic trends of chemical reactivity of alkali metals and halogens. Halogens, you know, group 17 elements. What about their reactivity? And the alkali metals, that is the group 1 elements. What about their reactivity? Go through the statements. Chemical reactivity increase with increase in atomic number down the group in both the alkali metals and halogens. If we are going down the group, the atomic number increases, the reactivity increases. In alkali metals, the reactivity increases, but in the halogens it decreases with increase in atomic number down the group. Option C says that the reactivity decreases in the alkali metals but increases in the halogens with increase in atomic number down the group. And option number D says that in both the alkali metals and halogens the chemical reactivity decreases with increase in atomic number down the group. So what would be the right answer? I'm waiting for my kids to answer. Be little more patient, guys. I will just take an hour of yours. Please, a bit faster. You have learned a lot. You learn about what would be the acidic character of oxides. Many such properties has been cleared. Unacademy offline. No, I don't teach offline, bache. I only take your Unacademy plus sessions. That is over there. I take only online classes. Danav Gaming D, no. The right answer is B, Danav. Let's have a look. If you are talking about the group 1, okay. So in the group 1, what happened? We have LINAK, So as we go down the group, the atomic number increases. The number of shells increases. So it becomes very easy for us to remove an electron in the case of cesium, and as the very low ionization energy is required, low ionization energy is required, this gives its electron very easily and it is most reactive, okay, and the reactivity increases, and we can say that the reactivity increases. So first of all, in the alkali metals the reactivity increases as the atomic number increases down the group. Okay, but what happened in the case of halogens, that is the group number 17, we have a fluorine, chlorine, bromine and iodine. Guys, halogens have a tendency to gain electron, they don't lose electron. Okay, they have a tendency to lose electron. There we will be having a loss of electron. But in the case of a fluorine, they have a tendency to gain electron. They gain electron. Now who will be having high electron affinity? The chlorine size will increase, bromine and iodine. So here the fluorine is very small in size, having high electronegativity, will try to pull the electrons. So ultimately, yeah, we know the electron affinity nature of the fluorine and chlorine, but in general what will happen? the electron affinity, the ability to gain electron is more as the atomic number is less, but as the atomic number increases as we go down the group, this tendency decreases, and so therefore fluorine shows high reactivity. Okay, so we can say that the halogens, it decreases with increase in atomic number. Okay, so as the atomic number increases, the reactivity decreases, the reactivity decreases. Okay, so the answer is different for both the cases. Okay, the group 1 alkali metals have a tendency to the loss of electron, but the group 17 and non metals, they have a tendency to gain the electron. So whosoever will gain the electron fastest will be more reactive. Okay, but as we go down the group, iodine has very less property, very less ability to gain the electron, so it's less reactive. Okay, so the right answer is option number B. Always remember this point. Another question, in which of the following arrangement the sequence is not strictly according to the property written against it? Okay, so let's have a look. If we have this order, okay, this is this kind of sign, increasing acidic strength. Is the acidic strength increases? These are the hydracids. They are also the hydracids. Is their basic strength increases? Boron, carbon, oxygen, nitrogen, increasing first ionization enthalpy, increasing oxidizing power. Will they be more oxidizing in nature? What would be the right answer? Not strictly. Not. The question is asking not according to the property against it. B. Absolutely. Yes, B is the right answer. So basically, what's the solution for the question is, what's the solution for the question is, let's have a look. Guys, you know HF, HCl, HBr. So as we go down the group, the electronegativity factor does not work. As we go down the group, the size factor works. Okay, so now here the hydrogen is very small in size, iodine is very bigger in size, so this bond strength is very poor. So this bond will be broken very easily. So that's how Hi is going to be a good proton donor. This is going to be a good proton donor, and we know that what are acids? Acids are those who are proton donors. So whosoever will give the proton easily is going to be more acidic. Okay, so Hi is going to be more acidic than HBr, then HCl, then HF. Now what about the thing? So here also the same thing should happen now. If we are saying that the SbH3, they are also the nitrogen, phosphorus, NPAS, Sb, Bi. So as we go down the group, the size of the atom increases, the bonding with the hydrogen becomes poor, this will give the proton easily. So the acidic character increases. So increasing basic character? No, increasing acidic character. Okay, the property is acidic character here, not the basic character. So which of the following sequence is not strictly according to the property? This. That's why B is the right answer. Otherwise this was the correct. If you would see ionization energy, just now I told you nitrogen being 2p3 will be having more ionization energy rather than it is easy to remove electron from 2p4 to gain the extra stability, but not from nitrogen. And what about this increasing oxidizing power? Yes, absolutely, they all are the dioxides. So as we go down the group, the oxidizing power increases. Okay, so you know what, they will be because here let me tell you the reason behind it. The carbon and silicon, they in their case the +4 oxidation state is more stable. This is more stable. Okay, but in the case of SnO2 and PbO2, their lower oxidation state is stable because of the inert pair effect. Okay, so as we go down the group, the size increases, the stability of the lower oxidation state increases. So Pb is more stable and it's +2 rather than +4. So this PbO2 wants to get into Pb +4 to +2, means there has to be a reduction. So when PbO2 wants to get reduced to Pb +2, means if this is undergoing reduction, means it's a good oxidizing agent. Okay, so here this is a good oxidizing agent. This order is also correct. The answer for the question is B. We move on with the another question. Yeah, we move on with the another question. The correct sequence which shows the decreasing order of the ionic radii of the element is decreasing order of ionic radii. They all are cations. So what happens in the case of ionic radii of the cationic species? Are they all isoelectronic or not? Please have a look and then answer. So who all are answering questions as of now? Yes, bache. Please have a look over all the ions that you are having. Okay, let's have a discussion. Aluminium, magnesium, sodium, fluorine and oxygen. This few are from period number 2, few are from period number 3. We can say that this is Li, Na, this is beryllium, boron, carbon, nitrogen, oxygen, fluorine. Just write the way I am writing. Okay, so here the question is asking about Al plus 3. Okay, Al plus 3, Mg plus 2, Na plus, F negative and O2 negative. Okay, so these are the ions they are talking about. So ultimately we can easily see that 2 electrons are adding, 1 electron are adding, they are gaining the noble gas configuration of anion. By losing all such electrons, they are also gaining the noble gas configuration of neon. So they all are isoelectronic. So let's remove all other species which are of no use for us. Okay, so they are all isoelectronic. So in the isoelectronic species, how the ionic radii increases as the number of electrons increases. Okay, number of electrons increases. Here we have a number of protons 8, number of protons 9, number of protons 11, number of protons 12, number of protons 13. So as the number of protons increases, the nuclear charge increases and they will try to attract the last shell electron more strongly and the size decreases. Ultimately what comes here is O2 negative has to be greater in size. So what is the right answer? This is the right answer, option number D. Okay, O2 negative, because less number of protons, they all are having the number of electrons as 10. E is equals to 10, electron is equals to 10, they all have same electrons, they all are isoelectronic, no? So ultimately the proton is going to decide, because if you will see the proton electron ratio, so as the proton electron ratio increases, the number of protons increases, the nuclear charge increases, size becomes smaller. So that's how the aluminium size is smaller. Okay, this is it. Another question, which one of the following orders presents the correct sequence of the increasing basic nature of the given oxides? You have to tell the basic character of the given oxides. Answer, Mr. Mamer. Okay, I would be looking forward. Okay, let's start. Aluminium, you know that, lithium. Here we have if you would see the elements which have been asked are basically, they are asking about the oxide of aluminium, magnesium, sodium and potassium. So while doing all such questions, you need to learn the approach of solving questions. Okay, don't just go through the question and give your answer. Learn the approach, how I am trying to solve the question for you. Okay, I always write down the elements where they are present in the periodic table. When you will be able to locate those elements, then only your mind will work. Okay, so now here we can see that sodium, magnesium and aluminium, we are going from left to right, and we all know that they all are basic in nature. They all are basic in nature. Reason being why they all will be basic in nature. Why? Because they belongs to S block elements. S block elements are basic in nature and the aluminium forms the amphoteric oxide. So first of all, the first thing first that I can understood is increasing basic character. So they all have to be acidic and the aluminium oxide is going to be basic. This is amphoteric. So by this only I can say that my answer has to be option number A, because aluminium oxide is going to be amphoteric and rest all are going to be basic. Now if you compare between all of them, then what will happen? As we go top to bottom, the metallic character increases, right? the number of shells increases, ionization energy becomes low. So low ionization energy, more metallic character. Okay, so the metallic character increases. Metallic character increases, the basic character increases. So Na and K, K2O is going to be more basic as compared to that of the Na2O. Okay. Okay. Now here if you compare between the Na and Mg, we are moving from left to right, the size is decreasing, ionization energy will be more ionization energy will be required, so less metallic matlab less basic. Okay, then comes your magnesium oxide. Very easy to answer such questions. Okay, Swapnil, it's fine, bache, but now you can continue because still 6 questions are left. So let's have a look what is happening. The increasing order of the ionic radii of the given isoelectronic species is the increasing order of the ionic radii. Now the question is itself saying that they are the isoelectronic species, means they have the same number of electron. So just have a look over who will be having a more proton. More proton means smaller the size. Simple. Same electrons. If you have same electrons, if you have isoelectronic species, look for the number of protons. If the proton increases, the nuclear charge increases. The nuclear charge increases, the size decreases. Increasing order of ionic radii. The question is asking increasing order, means this order they are talking about. Size is increasing. So what will happen? The right answer is option number C. Absolutely. Okay. We can see here the number of electrons are increasing. If you will see the position of these elements, we have K positive, we have Ca plus 2, we have sulfur S minus 2, Cl minus 1. So these are the 4 elements that we are having, and they are all isoelectronic, and we know that when we are moving from this to this, the atomic number is increasing. So this calcium is having the highest atomic number. Atomic number increases now, you go from this to this, then this to this, then this to this, the atomic number increases. So calcium is having the highest atomic number, so smaller in size. Calcium, then comes your potassium, then comes your chlorine and sulfur. The right answer is option number C. Absolutely amazing. Another question, which of the following represents the correct order of increasing first ionization enthalpy for calcium, barium, sulfur, selenium and argon? The question is about the increasing first ionization enthalpy. The ionization enthalpy has to increase. Done? Okay. We all know argon is a noble gas, will always be having a high ionization energy. That's why the order is about the ionization energy. What will happen? Of course, that's why in every option argon is having the highest ionization energy. Now how to decide? Just write all these elements where they belong to the periodic table, then find it out. We know that this group number 2, B, Mag, Ka, Sar, Ba, Ra. So if you would see all these elements, this is beryllium, we have magnesium. The question is not asking about beryllium and magnesium, the question is asking about the calcium and the barium. Calcium and barium, the size will increase. And what about the sulfur and selenium? So here we have oxygen, sulfur and selenium. Okay, so when you are going from, this is period number 2, this is period number 3, this is period number 4. So calcium to selenium, the size decreases, size becomes smaller. Okay, and then after you have argon, means helium, neon, argon. You have this argon. So argon being a noble gas, absolutely it will be having the highest ionization energy. Now you are comparing among calcium, selenium and barium. We know that metals have low ionization energy, right? These are the metals, and metals have a low ionization energy, means less energy is required to remove an electron. And if you will compare between the calcium and barium, barium size is bigger because the number of shells increases. Number of shells increases means less amount of energy is required to make it Ba+1. Okay, and then one more electron can remove to form Ba+2. Okay, so barium requires least ionization energy, so therefore answer goes to option number C. So first barium, then comes your calcium, they all are metals, metals has low ionization energy. Then comes your selenium, you have sulfur also. So when comparing between the sulfur and selenium, the number of shells increases, the ionization energy decreases. So of course selenium will be having low ionization energy as that of the sulfur. And then comes your argon. I hope the question is clear. Another question, the first ionization potential of sodium is 5.1 electron volt. The value of electron gain enthalpy of sodium ion will be. They all are the previous year questions. Please guys, in the session or after the session, if you have any doubt, please at least go through all the questions again, because they are extremely important for your JEE preparation. Okay, the first ionization potential means when I remove an electron from the sodium, the first electron I remove from the sodium, and to form Na positive, the energy required is whatever the amount of energy required is 5.1 electron volt. Yeah, absolutely. Whenever you do the ionization, energy is always required, means amount of energy is required to remove an electron, which is 5.1 electron volt. The value of electron gain enthalpy of Na positive will be. Now the question is, if you are having Na positive and if you want to gain an electron, okay, if the Na positive wants to gain an electron, then what will be the delta EGH for this, okay, to become Na. Answer, waiting for your answer guys. How much, what will be the electron gain enthalpy value? Any answer? B? Absolutely. The answer is B. Why? Because guys, here ionization energy is always energy required. It is always an endothermic process. Always endothermic process. Always endo. Okay, whenever you gain an electron, energy is required to add an electron. But when you are, when you are losing an electron, whenever you do the loss of an electron, energy is always required to remove an electron, always endothermic. So that's why this is positive ka 5.1. But when you are having Na positive and you are gaining an electron, so this is positive and this is negative, so they will be having attraction for each other. So when we are having the attraction, no energy is required. Electron gain enthalpy could be energy required or energy loss. So here, because there is a nuclear attraction, there will be a loss of energy. Loss of energy means energy released. And since the energy released, the process becomes exothermic in nature, and for the exothermic process, delta HEG becomes negative. And of course the same amount of energy needed for the gain, for the loss of electron, or the energy required for the loss of electron, or the energy released during the gain of electron is going to be the same in magnitude. So the right answer is minus ka 5.1 electron volt. Let's move ahead for the another question, which is the third last question. The ionic radii in Armstrong of N3 negative, O2 negative, F negative are respectively. What would be their values? Option number 4, movie. Hey Noob Master. You have joined the session late, no? If you really feel that chemistry you don't able to understand any time anyhow, guys, I would give you a very simple suggestion. At least go through few of my lectures, okay, on this channel, which are absolutely free for all of you. Yeah, it's a YouTube channel. So over the YouTube, I have created a complete course, which is a very precise course, and where all the concepts has been clear to you. Please go through them, and still if you find any difficulty, please do let me know. You will be having your mind change. Yes, right answer is option number A. Very good, Tushar. How? We know that they all are isoelectronic, nitrogen, oxygen, fluorine, they all belongs to period number 2. They all having the noble gas configuration that equals to neon, that is the total number of electrons are 10, 10 and 10, right? Why? Because this is N3 negative, O2 negative, F negative, and the number of protons 7, 8 and 9, and we know as the number of protons increases, the size decreases, so this is chota, this is more bigger, and this is much bigger, because here we have less protons and more electrons. So less protons and more electrons, so here we will be having more electron repulsion, and hence the size increases. N3 negative is larger in size, 1.71, 1.40, 1.36. This is the reason. Another question, which is the second last question. In general, the properties that decrease and increase down a group in the periodic table respectively are. This is a very recent question asked in JEE paper. The property that decrease and increase down a group in the periodic table. When you go down the group, when you go from top to bottom, which property decreases and which property increases? What's your answer? C. Absolutely. What happened when we go down the group? We know that as we go down the group, number of shells increases. As the number of shells increases, the atomic radii size increases. Size increases means atomic radii increases. Okay. And what decreases? Electronegativity. Okay, that is the tendency to pull the shared pair of electron decreases because the size is so large now. Okay, so electronegativity decreases and atomic radii increases. So this is the answer. Another question, the last question, the element having the greatest difference between its first and second ionization energy is. Which element is having the greatest difference between its first and second ionization energy? First and second ionization energy. Amazing. The right answer for the question is option number D. Why? We know that as we are talking about Li, Na, K, what will happen? They all belongs to group number 1. So here the electronic configuration is 2, 3, 4. We have 4s1. So whenever you will be losing one electron, it will become K positive. 4s0 means this will achieve the noble gas configuration of this is helium, neon, argon. This will achieve the noble gas configuration of argon, which is 2, 10, 18 number of electrons. And when you want to remove one more electron, then it's a noble gas configuration and its ionization energy. Now the value of ionization energy will be very high. A very high ionization energy, very high amount of energy is required to remove this electron, because now you are losing an electron from the inert and the noble gas configuration. Inert gas configuration. Okay, so this is the reason why potassium is having the greatest difference between is IE1 and the IE2. Okay, this is it. So whenever we reach the valential electron, there will be a high jump in between the successive ionization energies. Okay, absolutely. So guys, how was this session? Please do let me know if you really liked it, and if in anyhow this session helps you while in revising or concept clarity if you have got, then please do like the session and leave your comments. Okay, whatever, it's a positive feedback, it's a negative feedback, I am going to welcome all your comments here. Okay, please do that so that we get to know what you people are getting, what you demand. Okay, so what you want to learn, please do let us know through the comment section so that we may bring our sessions in that particular direction only. Okay, so guys, if you are not an Academy subscriber, it's fine. You just follow me on an Academy profile, because we do have so many free sessions, so much of content which is easily accessible to all of you. As you can see that in my previous sessions, you have seen this code Megha TG. So wherever you want to unlock any of the thing, any of the free session or free class, you just use a code Megha TG. And if you want to learn from us through the Unacademy Plus, then you do have a subscription. Do subscribe to Unacademy. It's an online platform. Amazing teachers are there. In multiple languages we are having the courses. So from whichever the corner you belong to, any country or India, you can have a chance to learn from us. Okay, so do follow me. There are already 127,000 followers which are following my profile and learning through my courses. So why not you? These are the 6,000 dedications which the students have dedicated to us when they have helped. And guys, let me tell you, I'm an Educator of the Month award I have also received, and I'm having an All India rank 25 in CSI UGC NET in chemistry itself. So that's how the chemistry is my whole soul subject. Whole soul, I'm very passionate about this subject. And if anybody says that my chemistry is like out of my box, so no, this is not going to happen if you're learning with me. Okay, so let's have a look. I will be coming up with more number of such sessions. I just need your love and your support, okay, so that we can come up with more number of sessions and can help you with so much of free learning. Okay, so see you guys. Have a nice day. And with this, I want to tell you that we are going to start with a very new topic after completing the periodicity. Now we are going to start with the GOC. So that is the basic concepts of organic chemistry topic from the organic chemistry section. So if you want to start your organic with me, then yes, I welcome you the most. Come forward. From today itself, my sessions will get started on GOC. Bye bye guys. Do subscribe to Unacademy JEE English.